Okay, so for the last two problems, we're going to actually be solving trig equations. So our goal is to actually solve for x or solve for theta, depending on what it is. And we are only looking at the interval from 0 to 2 pi, so that means all the way around the unit circle, except for we're not going to include 2 pi. So on this one right here, a lot of these you're going to factor. So this essentially is like a quadratic. So think about having like x squared term, x term, one term, kind of like we were looking at with e to the x when we were doing that in unit 4. So because it has a number out front, think about if you were to multiply 4 times 1, that will give us 4. So we got to find two things that multiply to give you 4 and add to give you negative 4. Okay, so that'll be negative 2 and negative 2. So because you have a number out front, you have to bring down your first term. And then your two middle terms is going to have negative 2 sine x and negative 2 sine x. And then you're going to bring down your last term, which is 1. And then we're going to do grouping. So the GCF between the first two terms is 2 sine x. If you take out 2 sine x, that'll leave you with 2 sine x. And then take out 2 sine x here, minus 1. And then if you group for the last two, we'll take out just a positive 1. Actually, let's take out a negative 1. So we can get rid of that. So I'm going to put plus and negative. And then, so if we take out a negative, that'll leave us with positive 2 sine x minus 1. So my insides are the same. So one factor is 2 sine x minus 1. The other factor is 2 sine x minus 1. Okay. So now that we factored this, this is equal to 0. So you can take each factor and set it equal to 0. It's the same thing, so you don't only have to do it twice. Okay, I'll just give you a double root answer. So if we were to get sine by itself, we add 1 over, and then you can divide by 2. So sine x equals 1/2. Okay, so remember they did give you an interval, so pay attention to that, but we know sine is the y value. So we're looking on our unit circle when the y value is 1/2. Okay. So if you have a unit circle handy, you can look at that. But the y value on the unit circle when it is 1/2 is at pi over 6 and at 5 pi over 6. So I don't have a unit circle put up, but just double check on your unit circle. The y value anywhere on the unit circle at pi over 6 and 5 pi over 6 has a positive 1/2 y value. This is the exact same thing here, so you don't have to do it twice. So this would be your two answers. Okay. So looking on the next one and the last one, it's very similar. So for this one, we're solving it as well. So the goal is to find the answers on the unit circle that would give you the x value that works. So the difference between this problem and the last problem, choose this one here, is that it doesn't have the same trig function. So if you do not have the same trig function, then you can't factor. Okay, so we need to make it the same trig function. So I'm going to take sine squared x, and I want you to think about your Pythagorean identity. So over here on the side, we know cosine squared x plus sine squared x equals 1. So I want to rewrite that where I solve for sine squared. So that means sine squared x is 1 minus cosine squared x. So I'm going to replace this sine squared with 1 minus cosine squared x, and then I'll have everything in terms of cosine. So 2 times, instead of sine squared, I'm going to put 1 minus cosine squared x, and I still have plus cosine x, and I still have equal to 1. Now everything is in terms of cosine versus being in terms of sine and cosine. So I'm going to go and distribute this out. And if you notice, we're going to have a quadratic here because we have one that's squared and one that's not. So we need everything on the same side and we need everything in the correct order. So if I put this, this will be negative 2 cosine squared x plus cosine x. And I need to subtract my 1 over here from this 2, so I'll have a plus 1. Okay, before I factor, you do not want to have a negative here. So because it's equal to 0, I can just divide every term by negative. So it'll make it positive 2 cosine squared x minus cosine x minus 1 equals 0. So now this is now like the problem that we just did a minute ago. So now we're going to factor. There's a number out front, so you're going to make sure you do AC method. So we're looking for two things that multiply to negative 2 and add to negative 1. So it'll give us negative 2 and positive 1. Bring down your first term. Two middle terms are going to have negative 2 cosine x and plus 1 cosine x. And you're going to bring down your last term. And then we're going to do grouping. So GCF is 2 cosine x. That'll leave us with cosine x minus 1. GCF here is just 1. That'll leave us with cosine x minus 1. My insides match. So we'll have cosine x minus 1. And the outside is 2 cosine x plus 1. Okay, that is equal to 0. So we can split it up into two different problems. So we have cosine x minus 1 equals 0. And we have 2 cosine x plus 1 equals 0. So if we start with the left-hand side, if we just add 1 over, we have cosine x equals 1. Okay, so you're taking a look at your unit circle. Hopefully you have a unit circle out. Your cosine is the x value, so we're trying to find on the unit circle where is x equal to 1. Okay, so x is equal to 1 at 0. So the answer for this side is 0. Now, it's really at 0 and at 2 pi, but your interval told you only wanted to look from 0 to 2 pi, and 2 pi is not included, so we're just going to put 0. Okay, and then on the other side, if we solve for cosine x, so cosine x equals negative 1/2. So we're looking on the unit circle where we have cosine, which is an x value, equal to negative 1/2. So there are two places where that happens. So if you look at 2 pi over 3, the x value is negative 1/2. And if you look at 4 pi over 3, that x value is also negative 1/2. So we have three different answers for that problem.